Next, we're going to hear about the emissions impacts of waste generation at Columbia.
Okay. Hi, everyone. I'm Chelsea, and this is our team. And our client was Columbia's Office of Environmental Stewardship, and we were tasked with quantifying and assessing Columbia's Scope 3 waste emissions. So, why calculate emissions from waste? Columbia is committed to taking climate action, and calculating greenhouse gas emissions is one of the ways in which you get that first information glance in order to tackle climate change policy. So Columbia is moving towards an 80% emissions reductions by 2050, and, sorry, a little short. And so there's Scope 1, 2, and 3. Scope 1 and 2 are required to be reported to the Climate Registry, and those include direct as well as indirect emissions. However, Scope 3 is optional, and that includes transportation and waste. So transportation was already tackled a little bit last semester, and we tackled waste. So how do we go about doing this? So as you can see from this graphic, we wanted to first start off with Columbia's Morningside Scope 3 waste emissions. We had academic portfolio waste that was already given to us in terms of tonnage, but we had to do research in order to quantify the correct greenhouse gas emissions coefficient. However, in the residential portfolio, we did not have access to data for waste generation. And so in order to calculate that, we then came up with our second deliverable, which was an extrapolation. And so for this extrapolation, we essentially took data from other sources and then applied it so that we could get an estimate of what Columbia's residential portfolio looked like. However, we realized that in the future, in order to get a more accurate estimate, it would be helpful to get down and dirty into the bags. And so we put forward a methodology for the waste characterization, and that's our third deliverable. And then for our fourth deliverable, we actually went in ourselves and started quantifying some stuff in the bags. So to talk about this first data gap in terms of our extrapolation, here is Diana.
Hello. So as Chelsea just explained, the first step in our process was trying to estimate how much waste our residential portfolio produced because we didn't have the data for that. So me and my teammate developed an extrapolation methodology to try and estimate that. And our extrapolation methodology is based on a calculation of how much waste a single person produces in Community District 9. And Community District 9 is the larger community that Columbia University residential portfolio is a part of. So using the available data of DSNY, essentially DSNY collects the waste in the community district and then publishes this information online. So we used that data and the known population of Community District 9 and calculated how much waste in the respective streams a single person produced every month. And then we also estimated the population for our residential portfolio because we also did not have the data for that. And to do that, we used a small available sample of undergraduate housing for which we knew the population for and the square footage and then did a regression model to predict the population for the rest of the residential portfolio. Once we had the population and how much waste a single person produces, we multiplied that to get how much waste is produced in a single residential building, and then we aggregated that to get the total monthly tonnage for all the buildings. And then one last thing that our model did is that we adjusted our baseline results to account for the seasonal changes when students leave for summer holidays and December holidays because our original model did not account for that. And so here are our results. So in 2018, we predict that our residential portfolio produced about 4,600 tonnage of waste in total. Refuse makes up about 80%, while our recyclables, MGP, and paper make up 20%, 10% each. Organics makes up the less than 1%. And one thing to note is that even though this is an extrapolation, it really follows the trend that is happening at the university. For instance, our peak months are May, August, and December, and that's when students are moving in or out, and we expect a lot of waste. And then looking at the trend over the years, waste has decreased overall, and our diversion rates, which is essentially the rates at which we recycle, have improved, but not that much. In 2008, for instance, our recyclables make up about 16%, whereas in 2018, as I described, is about 21%, so a slight improvement. Yeah.
So for the next stage of our project, my teammate and I estimated the overall greenhouse gas emissions from the treatment of waste, in part relying on the results from the extrapolation that Diana described. So we combined the extrapolated extrapolated waste generation from the residential portfolio and combined it with data we already have about waste generated by the academic portfolio, also called the Grove. And then using appropriate emissions factors that we located, we converted that waste into overall greenhouse gas emissions from municipal solid waste, or MSW, which is refuse that goes to landfills or combustion facilities. And For recycling and compost, we instead calculated avoided emissions for a number of reasons, mainly because of concerns surrounding double counting. And here, when we talk about avoided emissions, we're talking about the emissions we avoid by sending these materials, by not sending these materials to landfill, and also by using recycled and composted material as inputs in the manufacturing process instead of virgin materials. So to perform these conversions, we created a spreadsheet, a GHG tool, pictured here. And this tool has a variety of different features, including the ability to toggle between different waste composition and waste management scenarios. So our first results for 2018, our greenhouse gas emissions from waste for the academic portfolio, or the Grove, are 2,712 metric tons of carbon dioxide equivalent. And here you can see that the emissions pattern follows the overall waste generation pattern that you would expect. So there's the predictable dip during the summer months. You can see the peak in September during move-in, another dip during January, reflecting the effect of winter holidays perhaps, as well as a relative peak in December, perhaps because of finals or the holiday season. For the residential portfolio, the 2018 total was 2,975 metric tons of carbon dioxide equivalent, and here there's not nearly as much variability, so you can see that there's a nearly constant 250 metric tons emitted every month throughout the year, although there is a peak in August, again, perhaps because of move-in, and a dip in February. When we combine when we look at the profiles side by side, you can see that they're quite comparable and that the Grove emits almost as much as the residential portfolio throughout the year on a month-by-month basis, with the 2018 total being 5,688 metric tons of carbon dioxide equivalent. But when we look at avoided emissions, it's quite a different story. So the Grove makes up a much smaller portion of avoided emissions. And we think this is in part due to very different recycling behaviors, especially when it comes to paper recycling. So for avoided emissions, our estimate ranges from negative 4,343 to negative 6,461 metric tons of CO2 equivalent. So overall, we hope that this tool will be very useful for Columbia moving forward as they consider their waste management strategy as well as possible educational initiatives. Although we do realize that this tool relies on a number of assumptions, including the extrapolation itself, which relies on assumptions as well. So we hope in the future to be able to replace the extrapolation with a comprehensive waste characterization study, which will improve the accuracy of these results. And Silbo will talk about that.
All right, great. Thank you. So our waste characterization methodology is set to supplant the extrapolation tool in the not-so-distant future, hopefully. So what is a waste characterization methodology? It is a series of processes used to determine waste generation and tonnage, particularly here at Columbia, and it's broken down into three distinct phases: sampling, sorting, and handling. Through our rigorous study and literature review, we determined that Columbia could greatly benefit from a waste characterization study because it is possibly the most accurate way of measuring, recording, and reporting waste tonnage and composition for the residential portfolio. Additionally, as I stated before, while the extrapolation method is convenient, it's rather flawed because of the assumptions it is based upon, and the waste characterization methodology can help determine greater waste diversion. But where do we begin? We begin by first determining sample size. While Columbia has 250 buildings, the most accurate way to determine our waste tonnage and generation would be to sample them all, but it's rather costly and time-consuming, so we need to first determine an appropriate sample size. If we assume all buildings are unique entities, the sample size would be rather large, which might not help us, but if we assume that all buildings are identical within unique categorizations like residential halls, mixed-use office buildings, and academic halls, the sample size will be significantly reduced. However, more research does need to be conducted on determining sample size because building sample size metrics is quite different than determining sample size among human population. Thank you.
Thanks, Silbo. My name's Alexander, and I was tasked with spearheading our mini survey, or on-the-ground survey. As we coined it, the petite survey. This petite survey ultimately wanted to inform our methodology because ultimately what better educator than experience? We took an ego check. We dressed up like a bunch of Ghostbusters and got out there and counted bags. Through the petite survey, we were able to get access to 4 buildings, thanks to the clients for enabling us to do that. Of these 4 buildings, we were able to do a total bag count of waste generated over the course of 24 hours. For those 3 buildings, it was McBain, an undergraduate residential hall building, 431 16th and 438 116th, both faculty buildings. Major takeaway from our preliminary results were much more of the undergraduate waste production was going to landfill. Those black bags made up about half of their recycling bags, the clear bags. Only about 27% would be headed to recycling plants due to contamination, the contamination being an 18% threshold. We did a waste composition of McBain. So that meant we cut open the actual bags, got dirty. It was quite a smelly endeavor. Our results were fairly interesting, though. So of the black bags, only about 43% should actually be headed to landfills. The rest could possibly be headed to recycling plants. And as we looked at clear bags as well, we saw that there's a fair amount of contamination of the clear bag that we did a sample of. It was around 20%. This means it wouldn't actually be headed to a recycling plant, but instead a landfill. And then finally, we went into 438 116th. It was the residential property for a lot of the senior faculty at the university, including the provost. And they actually did an incredible job. So of their black bags, 65% should be headed to landfills. They did obviously have some more recycling opportunities, but of their clear bags, they had very little contamination, meaning DSNY would indeed accept their recyclables. So hats off, Provost. Thank you very much.
Okay, so just to finish up, what we've discussed and what we've completed for the project is a useful tool for estimating GHG emissions both now and in the future, as well as a methodology for estimating waste tonnage through extrapolation, and eventually, to replace the extrapolation, a methodology for future sampling work in estimating waste tonnage. And we got a little glimpse of what that would look like in terms of our little survey. So some suggestions for future work in terms of Columbia. Education initiatives. So as Alexander just mentioned, we've had, when we dug through the bags, we noticed that there was quite a bit of contamination for the undergrads. And so there's really potential to hammer in what to recycle and what not to recycle. And then also possibly having work study student groups and possibly consultants for conducting the large-scale waste audit in order to get more accurate data. And just to finalize, we know that in order to take appropriate action, one of the most important first steps is having good information. And so we believe that our project has really helped give Columbia that first initial step in taking appropriate climate policy. Thank you.
Great project, great presentation. I'm fascinated by this difference between the faculty and the undergraduate residents, and it's very hard for me to believe that faculty is so much more enlightened than undergraduates. So what do you attribute that difference? Is it that there are more instructions in the faculty housing, or there's easier pickup, or did you get any sense of what precisely it was that could account for that difference?
None of the surveys that we did were statistically significant. Obviously, we were limited in terms of time, so we weren't able to do multiple of these audits for an individual building. But ultimately, if I had to guess why the faculty had so much more compliance, I think the fact that they're year-round residents and they're living in that building continuously probably contributes to the fact of them wanting to be I don't want to say more productive members of the community, but certainly more compliant in terms of their recycling habits and things of that nature. Especially in the waste pickup zone that they had in the basement, there was, very clearly marked out recycling containers with posters, with, images of what you could and could not recycle. It made it really clear for those individuals. And ultimately, those people are supposed to be the leaders of our university. So I think the one thing that was, reassuring to me is, at least at the top end, we're doing the right stuff. I'm sure there's also a component of care, especially for the undergraduate students. I think really trying to get those undergraduate students involved in the recycling process and recognizing how much of an opportunity we have is really vital. I know after, I did the waste audit, I was much more careful about where I'm placing my trash, and I can, vouch, I'm sure, for the rest of our group that we're much more cognizant of our recycling and trash habits.
So, what's the threshold for recycling to be accepted?
Stay up here. So recently, with China's Blue Air Initiative, the threshold has gone down, so it's now at 3%. But originally, it was at 18%. So DSNY was recycling any clear bag that had contamination level under 18%. We did this via a visual survey, and obviously that comes with its fair set of challenges and limitations, but that's the number we picked because historically that's what DSNY does.
Sorry. Do they not do a physical survey? A visual survey? How do they gauge what's?
So the DSNY is also conducting something similar to that, but it, like I said, comes with its fair share of limitations, and we're not professionals, so that's why the consultants are needed.